What's going on, everybody? It's your favorite Mr. Grossarth. Welcome to week 2 of remote learning. I miss you guys very much. I wish we were back in the classroom doing this thing together, but here we are. So let's get right to it. Before we get into today's lesson, I want to go over a quick review. Some of you had some questions for me about layer and understanding what a layer is when we're talking about volume. So let's take a quick look here. It says, what is a layer? A layer is a portion of a larger prism that we use to calculate volume. So what that really means is, think of it like this. Mr. Grossarth ordered a pizza. Of course I did, because I love pizza. And I want to find the volume of the box. So what I do is I look at the measurements of the box, which is the length is 12, the width is 12, and the height is 3 inches. So I do 12 inches times 12 inches times 3, or length times width times height, which I'm sure you know already by now. And I get a volume of 432 inches cubed. That's one layer. Now if I wanted to order 2 pizzas, I can calculate the volume very easily. Rather than going 12 times 2 times 12 times 2. No, I already know the volume of one layer, which is 432. So adding another pizza box with the same volume is 2 layers. So I just do 432 times 2, which is going to give me a volume of 864 inches cubed. Now if I wanted to add a third pizza box, I would just do 432 times 3. If I wanted to add 4, I would do 432 times 4. And that's how layers work when you're talking about volume. You have to just think of it like big old pizza boxes. And when you stack them up, if you know the volume of one pizza box, then you can easily calculate the volume of the whole thing without doing these longer measurements. You just do, the volume of the first pizza box times how many pizza boxes that you have. That's how you calculate volume using layers, okay? So today we're going to be solving word problems of rectangular prisms, and we're going to use the same strategies we've been using in class. I want you to write your notice and wonderings. It will help you. And we're going to be using the cube strategy. Yes, I made a mistake on my chart and I didn't feel like rewriting it because it's so beautiful, so I just crossed it out, okay? So cubes means we circle information. Those are the numbers. We underline the question. We box math words. We evaluate or write the equation and solve. This is nothing new to you. We've been doing this since really the first day of 5th grade and even before 5th grade. We're just going to use this as a strategy to help us. So let's break down the first problem. I'm going to read this out loud. Okay? Jeffrey's planter is 8 feet long and 2 feet wide. The planter is filled with soil to a height of 3 feet. What is the volume of the planter? Explain using a diagram. So let's go back and use the good old cube strategy for this. So I'm going to grab my marker. And I'm going to circle the information. So I see 8 feet long. I see 2 feet wide. And I see filled to, 3 feet. That's the height, is 3 feet. Okay? I'm going to underline the question, what is the volume of the planter? So I circled, I underlined. I'm going to box math words. Okay, I see length, width, and height. I see volume, so I'm going to go ahead and box that. I see the length, the width, and the height. So these are all words that are going to really hint and, tell me what I have to do, which is volume, because it says it right here. So that's a no-brainer. And so I boxed math words. I'm going to evaluate. So I'm going to write my equation. What do I have to do? But it doesn't just tell me to write an equation. It says to use a diagram. So I'm going to go ahead and I'm going to draw this planter. So it has, I'm going to draw a planter, which kind of looks like a rectangular prism. Remember, Mr. Grossarth, there's no artist here, so bear with me. And it's 8 feet long, 8 feet. It's 2 feet wide, that's 2 feet, and 3 feet high. So how do I calculate volume? Volume equals length times width times height. So I'm going to do 8 times 2 times 3. 8 times 2 is 16 times 3. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4. So it has a volume of 48 feet cubed. That one was, I think, pretty straightforward, pretty simple to the bone. Length times width times height. You're not always going to get word problems that are that straightforward. Okay, that's why word problems exist, to make your life very difficult, of course. So let's go on to the next one. So this is going to be a 3-part problem here that we just did part 1. Let's look at part 2. Jeffrey wants to grow tomatoes in 4 large planters. He wants each planter to have a volume of 320 cubic feet, but he wants them all to be different. Show 4 different ways he can make these planters. All right, so what I'm going to do is, this is a longer one, and this one, I think, in my opinion, is just a little bit more difficult than the previous one. So what I'm going to do is I'm going to create my KW chart. It's just going to make things a lot easier for me. So let's do what I know about this problem and what I want to know. Okay, so let's go ahead and go over what we know about this problem. Is that he needs 4 planters. So he needs 4 planters. Okay? So we're going to probably have to be dealing with 4 different planters or 4 different things here. Okay? He wants each planter to have a volume, so each has a volume of 320 feet cubed, okay? But he wants them all to be different, so I want to know what the difference is going to be. That's not something that is the problem's telling me, so I want to know what I can do to make these planters different, but to have them have a volume of 320 feet cubed. Show 4 different ways Jeffrey could make these planters. So of course I want to know what strategy I'm going to use. I know what operation I'm going to use. I'm going to use volume. So I'm going to put that in the no. I know that I'm using volume. Okay, because it tells me here, it tells me all over the problem. So let's go ahead and break down the information in the problem. So I need each of my planters to have a volume of 320 cubic feet. But he wants them all to be different. All right, so in other words, I need 4 different ways, 4 different length times width times height that can give me 320 cubic feet. I need 3 different ways I can get that. All right, so let's label them A, B, and C. So A, I'm going to kind of think about 320. What times what times what will give me 320? Well, since I see a 0 here, I'm automatically going to do 10. Okay, so that's one number. So then let's break down 32. What 2 numbers, when I multiply them, give me 32? How about 4 and 8? So 10 times 8 times 4 could be the dimensions of the first one. Okay, how about B? Let's stick with 10. Okay, so I have 10 times 8 times 4, that's the first one. The next one is going to be 10 times, what's another 2 number, since I've gotten rid of the 0 here because I used 10. What's 2 other numbers when I multiply them gives me 32? How about 16 and 2? So 10 times 16 times 2. So we have 2 planters ready to go. For the third one, I'm still going to stick with that number 10. I want to try and use this number 10 as much as possible because it makes my life so much easier when I use factors of 10. Okay, so how about 10 times 32, which will give me 320, but I need that third number, which of course could be 1. Okay, so I have 10 times 32 times 1. And now I think I've kind of run out of opportunities to use 10 here. So I'm going to have to try and switch it up. So for the last one, how about instead of 10, I use 20. Okay, so 2 times what will give me 32? How about 2 times 4 will give me 8, and then 8 times what gives me 32? 4. So 20 times 4 times 4. Okay? There's one last problem. we're going to go over now, before we get to the homework, and your problem set, and then the homework. Jeffrey wants to make one planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter. Okay, so let's go ahead and draw this, right? Why don't we just go ahead and draw this, because we know. I'm going to simplify our KW chart now, because we know that we have 3 feet is the height, okay? Because it starts 3 feet off the ground, so we know the height, okay? What we want to know, I should really say 3, but what 2 numbers multiplied with 3 give us 36. In other words, we know the height is 3 times blank equals 36. Okay? So let's go ahead and, there's actually a very simple way we can break this down. We're going to use the information that we know to find the information that we want to know. So I'm going to take the 3, okay, and I'm going to divide it into 36. So I'm going to do 36 divided by 3, which is going to be 12. So now 3 times 12 is 36, but that's not really what I'm interested in. Okay, I'm interested in breaking this down into 2 other numbers, right? I have to split this into 2, because this will give me 3 times blank times blank. So what 2 numbers, when I multiply them, give you 12? So how about 2 and 6, right? How about 2 and 6? I have a little challenge for you. Pause the video now. Not yet. I'll tell you when. What is another 2 numbers I could use besides 2 and 6? Pause it now. Okay, so now that you're back, think about another 2 number that gives you 6, because 3 times 2 times 6 is going to be 36. How about 4 and 3? That'll also give me 36 inches cubed. All right? All right, guys. That is your really today's lesson. Just breaking it down and making sense of the numbers. Watch the other video that I posted from Engage New York. Look at the chart. The finished chart will be up. Problem set and homework, get them done sooner than later. This way you're just not crammed with work at the end of the week, all right? Really quick thing is that we're going to be having a mid-module assessment. I'm going to post it for Friday, and I'll give you guys over the weekend to finish it. So you got plenty of time. I expect perfect scores on all of them, all right? See you guys.